Hey everybody, this is section 2.2 conditional statements. A conditional is just an if-then statement, so we read it as if P then Q, or P implies Q. The hypothesis is going to be just the part P following the if, and the conclusion is just going to be the part Q following the then. Alright, so if we look at this, what are the hypothesis and conclusion of this conditional? If an animal is a robin, then the animal is a bird. Well, the part following the if statement is an animal is a robin, so that would be your hypothesis, and the part following the then statement is the animal is a bird, so that would be your conclusion. Okay, if we look at the next one, if an angle measures 130 degrees, then the angle is obtuse. The part coming after the if statement is an angle measures 130, so that would be your hypothesis. And then the part after the then statement is the angle is obtuse, so that would be your conclusion. And that is your hypothesis and conclusion of an if-then statement. Okay, so if we want to go backwards now and be given a statement and we want to write it as a conditional, so write it as an if-then statement, we just think about what our hypothesis and conclusion would be. So vertical angles share a vertex. So we could think about our hypothesis, and that would be if an angle is vertical, then they're going to share a vertex. So you just wrote your conditional. If two angles are vertical, then they share a vertex. So we took a statement and wrote it into a conditional statement. All right, finding the truth value. So a truth value is either going to be true or false. So if the conclusion is false, then we're going to have to find a counterexample. So basically we look at this one. If a number is divisible by 3, then it is odd. Okay, well, we think about the numbers that are divisible by 3. There's 3, 6, 9. Well, 6 is obviously divisible by 3, but it's not an odd number. So we know that this conditional is false, and a counterexample would be 6 because it's divisible by 3 and it's even. So a counterexample is just something that you figure out when you know the statement is false. Okay. Related conditional statements. So the negation of a statement, P, is the opposite of the statement. So it's read as not P with the little symbol that we have right here. Okay? So the conditional is just the statement that we've been talking about. So if P, then Q. All right, the converse is just taking the P and Q and switching them around. So if Q, then P. The inverse is just going to be negating both of them. So if not P, then not Q. So it's the order of the conditional, but both of them negated. All right, and then the contrapositive is actually taking the converse and negating both of those. So we're going to have if not Q, then not P. All right, so let's look at an example of this. So our conditional would be if the measure of angle A is 15, then angle A is acute. Well, that is true. Okay, so the converse of that would be if angle A is acute, then the measure of angle A is 15. Well, that's going to be false, because if A is acute, then it could also be 89, 87, all those different degrees below 90. Okay, so an inverse then is going to be, remember, taking the conditional and just negating both of them. So if the measure of angle A is not 15 degrees, then angle A is not acute. Well, that's going to be false as well, because if we have a 30-degree angle, it's still acute, but it's not equal to 15. A contrapositive then is, remember, taking the converse and negating both of those. So if angle A is not acute, then the measure of angle A is not 15. That is true, because if it's not acute, it obviously cannot be 15 degrees. So that's just an example of a conditional statement and coming up with the converse, inverse, and contrapositive of that, and telling whether the truth value is false or true. Okay, so here is another example of writing and finding truth values of statements. So if the figure is a square, then the figure is a quadrilateral. Okay, so that's your conditional statement. All right, the converse of that would be if the figure is a quadrilateral, then the figure is a square. So we just reverse the order of the if and then statements. Okay, this is going to be false. A counterexample of that would be a rectangle. That is not a square. Okay, the inverse then is going to be if the figure is not a square, then the figure is not a quadrilateral. So we said if the figure is not a square, then it is not a quadrilateral. We took and negated both the if and then statement of the conditional. So that is also going to be false. A parallelogram is not a square, but it is a quadrilateral. Okay, and then finally the contrapositive, remember, is taking and negating both of the converses. So if the figure is not a quadrilateral, then the figure is not a square, and that would actually be true. So we don't need to come up with a counter example. All right, and then finally the last thing here is biconditionals. So if we have a biconditional, it's going to be a single true statement that combines a true conditional and its true converse. Okay, so you're going to join the two parts of each conditional with the phrase if and only if. All right, so the converse of this conditional is if the sum of the measures of the two angles is 180, then the two angles are supplementary. That's true. Okay, the converse then is going to be if two angles are supplementary, then the sum of the measures of the two angles is 180. So we just reverse the hypothesis and conclusion. And so both those are true. So that means that your biconditional then is going to be putting those two statements together with the words if and only if. So two angles are supplementary if and only if the sum of the measures of the two angles is 180. So that is your biconditional. All right, and that is it for your conditional statements. We will see you later.